hypothesis test with larger samples. Example 8, you flip a coin n equal 20 times and turn up heads x equal 11 times. So the proportion of heads, p hat, 11 over 20, 11 divided by 20 is 0.55. So that's a little bit more than we expect if the coin is evenly weighted. If the coin is evenly weighted, we expect the heads to turn up half the time. This is a little bit more than half, but it could have been a little bit more than half just by chance. So we want to know if this is enough evidence to say that the coin is unevenly weighted. Okay, so the null value, if the coin is evenly weighted, we expect the coin to turn up heads half the time. So 1 divided by 2 is 0.5. And the other null value, the proportion of tails, would be 1 minus p, or 1 minus, that's represented by q, 1 minus p, or 1 minus 0.5, and that's 0.5. And at the alpha equal 0.05 level of significance, we want to test h naught, p equal 0.5, the coin is evenly weighted, versus h1, p not equal to 0.5, the coin is unevenly weighted. So this is not equal to symbol is a two-sided alternative. The coin would be unevenly weighted if there's either more heads than tails or fewer heads than tails. So it's a two-sided hypothesis test. Okay, so step 1, we want to check that n times p is at least 5 and n times q is at least 5. Our sample size is 20, and for p we're using the value of p if h naught is true, 20 times 0.5, which is 10, greater than or equal to 5, and that's a yes. And then n times q, q would be proportion of tails, is also 0.5 if h naught is true. 20 times 0.5 is 10, greater than or equal to 5, and that's a yes. So we got 2 yeses. So that means we can use the z table to find the approximate probability. Okay, so the next step, if h naught is true, then the sample proportion p hat has mean or expected value 0.5. On the average, p hat should agree with the population mean, 0.5, and the standard deviation, square root of p times q over n. And these values are assuming h naught is true. So p is if h naught is true, p is 0.5, q is 0.5, and our sample size is 20. So we can do this, put this in the calculator all in one step. Second square root, second square root of 0.5 times 0.5 divided by 20, and then push equals at the end, and I get 0.111, 803399. Okay, so I want to store that in memory, so I don't have to retype it on the next step. And then we can compute this test statistic. So this is, you might recall a z-score from earlier in the semester, the score minus the mean divided by the standard deviation. The score here is going to be our sample proportion, which is 0.55 p hat. The mean of p hat is 0.5 if h naught is true. Standard deviation is 0.111803399 if h naught is true. Okay, so we have to do the numerator first because the subtraction comes before a division bar that goes all the way across underneath it. So it's 0.55 minus 0.5 and then equals 0.05. And then we can divide by the denominator, 0.111803399. Okay, so I put this in memory so I don't have to retype that. So put divided by second recall equals, and approximately 0.45. Okay, so our test statistic is 0.45. Okay, so the next step is to look up the test statistics in the z-table to get a p-value. Because we are doing a left-tailed test, or because we're doing a two-tailed test, and because our z-table is left-tailed, we'll use the negative side of the z-table and multiply by 2. So this is, we want the probability that z is greater than 0.45 or less than negative 0.5. It's a two-tailed test. So we want to include both extremes. So what we're going to do is just look up the one side. The bell curve is symmetric, so the left side is the mirror image of the right side. So these areas are equal, and we only have this area here. The probability z is less than negative 0.45. It's a left-tailed table that we're using. So it's going to be 2 times the probability z is less than negative 0.45. We want to use only the left side. And then we can look in row negative 0.4, column 5 of the z-table, and see what we get. Negative 0.4, column 5, 3264. And then multiply that by 2, we get 0.6528. Okay, so that is more than alpha. Alpha is 0.05. So that means we failed to reject H naught. Sample does not provide enough evidence. To say the coin is unevenly weighted. Okay. So it's possible the coin is unevenly weighted, but this is not. It's just this sample does not provide enough evidence. We don't accept H naught. Because of the awkwardness of the language, sometimes you might see in a textbook or in my lab accepting H naught, but technically we never accept it. It might be that maybe the coin is evenly weighted, maybe it's not, but this evidence from this sample is not enough to say that it's unevenly weighted. And that concludes this presentation.